Hi, can you hear me?
Yes, we can hear you.
Okay, so my name is Sarah Mena. I work for a 3D printing company, and
Yes.
I'm going to take you through the things that you just mentioned. But I'm not going to tell you how you're going to print a gun.
Yes.
But we'll talk about 3D printing in the medical field. So with me, it's also my colleague Farina, who is an application engineer. We work together, and she has this knowledge for more than 6 years. So we're here to answer your questions, and I'm looking forward to impart as much knowledge as I have about 3D printing to my fellow Kenyans.
Thank you. All right. Can we have Rosemary introduce herself before we now proceed with sorry, Rosalind. My apologies, Rosalind. Kindly.
All right, very well. My name is Rosalind Wanjiro, and I work with Kesha Labs. I am an economist and I'm a consultant in blockchain technology. So that just means that I help people understand how to appropriate technology to various industries and for various use cases. So I look forward to sharing more knowledge in today's session.
Thank you very much, Rosalind. Asante sana.
Great.
So,
Asante.
Sarah.
Yes, please. Can you see I'm sharing my screen with you. Can you see it?
Yes, we can see the evolution of medical industry with 3D
Okay. All
I'm
right.
hoping you can see. If you cannot actually see this, please let me just know. Julius, you can see, I believe we all are able to. Great. So, Sarah, I believe you can proceed with the presentation.
Okay. Thank you very much, Sudi, and thank you for the opportunity. So in my introduction, 3D printing is a 25 to 30-year-old technology, but it has recently hit its inflection point. In fact, I believe all of us are right now living through an industrial revolution. Exponential technology, of course, is disruptive. It can take down entire industries in what seems like a matter of time. So I'm going to talk about the Kodak moment to explain more about the evolution of 3D printing. In 1996, Kodak was a $38 billion company with 140,000 employees. In 2010, Instagram is born. 2012, Kodak declares bankruptcy. 2 months later, Instagram is acquired for $1 billion with a valuation of only around 13 employees. Now, the reason this happened is because Kodak did not really understand what business they were in. Therefore, my objective for today is to keep you updated with one of the 4.0 industrial technology so that what happened to Kodak does not happen to any of you or any of us. So what is Industry 4.0? 3D printing is a really exciting technology. We see entire industries like manufacturing, construction, and packaging being significantly disrupted. I'm sorry. And at some stage, we all might have our own 3D printers in homes and offices. We never know. Advanced digital technology is already used in manufacturing, but with Industry 4.0, it will transform production, for example. It will lead to greater efficiencies, change traditional production, relationships among suppliers, producers, customers, as well as between human and machine. There are 9 technologies which form the building blocks of Industry 4.0. I'm not going to go through all of them, but among the different manufacturing processes that are currently adapted by the industry, 3D is an addictive technique, as you can see among the 9 building blocks. So what is 3D printing? I'm sorry for that. So 3D printing,
All right, all right.
Okay, yeah. I'll just go ahead as I sort this out. So 3D printers are very popular right now. People are talking about 3D printing, but many of us are still not exactly sure what 3D printing is. So what is it anyway? It has very little to do with the laser jet printing sitting in your office at home that uses paper and printer ink cartridges, for example. And to boil it down, a 3D printer is a machine that can print actual 3D-dimensional models and objects. Traditionally, when we think of printing, we think of printing something on a piece of paper using ink, for example. But well, for 3D printing, first you need the appropriate 3D printing CAD software to make a digital model of your 3D design on your computer. To actually print and produce a 3D model, you'll need some ink. With traditional printing, we think of different syringes filled with ink. But in 3D printing, you have different syringes filled with different types of liquid consistencies. So this could be plastic, it could be rubber, it could be metal. You have a digital image that you can create using a different animation software. You then connect this image with the 3D printer and it actually takes that, it analyzes it and prints it out in a physical form layer by layer. So what can you make? Now, manufacturers have been using 3D printing for decades. You can print car parts, you can, aerospace industries are now using this and more and more. We're experiencing doctors using this, using patient-specific implants. The fashion industry is now 3D printing sunglasses, for example. There are basically 4 technical steps which are required to finalize a printed model in the medical sector. They include image acquisition. This is where you select the anatomical target area. The second, segmentation. This is the development of the 3D geometry through the processing of the medical images coming from a CT or MRI scan. And then we have file optimization. This is the optimization of the file for the physical printing. And finally, we have the 3D printer and material selection, which is where this is the appropriate selection of the 3D printer and materials. So where are we? Where is Kenya now? So there are quite several examples, but I will only dwell with 3. And I'll start with something. Did you know that in 1990, a novel project to manufacture motor vehicles in Kenya was abandoned due to the high cost of building 5 prototypes? Now, today, new technologies such as 3D printing are making it possible to not only develop prototypes at a fraction of what it cost a few years ago, but also provide us with the capacity to create more complex products than ever before. Now, 3D printing has provided homegrown solutions, and as you can see from my screen, in 2014, a 20-year-old student from Nairobi University used what we call a MacroBot 3D printer to develop a minuscule vein finder to use with children. And his objective was to develop proper healthcare and vein vaccinations to babies. We also have HappyFit. So we have engineering students who designed HappyFit. These are 3D printed shoes for Kenyans inflicted by, I believe we all know about the Moranga story with the jig infection. I'm sorry. So, and this was made for mobility hole and also lessening chances of reinfection. Now I can go into details as for the benefits of that shoe, but I will just take you through my other example, which is Kenya Connect. It's a non-governmental organization which is offering STEM and art classes in 3D printing in an effort to develop the technology at the grassroots level and create a generation that will fully harness the technology. So you can already see this is a student in Kenya who is watching in delight as an image emerges from the 3D printer. So I'm slowly going to take you through the role of 3D printing in the medical field. So medical 3D printing was, I believe it was once an ambitious pipe. However, time and investment has made it real. Every year, 3D printing offers more and more.
All right, I'm just sorting that out.
Okay.
Yeah. Continue.
All right. I was talking about the role of 3D printing. So every year, 3D printing offers more and more applications in healthcare. Sudi?
Just a moment.
Okay, let me know when I can continue.
Right. All right.
Yeah.
Let's proceed.
So I have two case studies to explain this. The first one, it's 3D printing has brought a solution where there is no other solution. Now, this is as recent as May this year, where a South African doctor pioneered a transplant of a patient's middle ear using 3D technology. I'm happy to say that this is the first in the world, and it gives hope to many of those who are suffering from loss of hearing. So Professor Mashudi, he's the one who performed the surgery. He focused his PhD over the last decade on conductive hearing loss and came up with the idea of using 3D technology to recreate any of the inner bones that may be damaged, thus resulting to a patient's hearing loss. I will quote unquote in his words, that is Professor Mashudu, he says, 3D technology is allowing us to do things we never thought we could. And this is a very good example, and I'm happy to say that Africa is now really on the map because this is first in the world. The second one, we use 3D printing for personalized pre-surgical treatment and for preoperative planning. So now what you see, this is an example of a hip implant, and this is done to patients who have hip injuries. And mostly this is done after a hip revision. And the hip revision is mostly the second or the third surgery when the first one doesn't work. So 3D printing makes it possible to create very specific and complex shapes, as you can see. This is therefore an ideal technique to design an implant that fully matches the patient's anatomy. So this is, again, very patient customized, very specific. So before the surgery, the plastic bone model and the implant trial serves as a reference for the surgeon to prepare the site and position of the implant correctly. So the implant itself reconstructs the center of rotation to the desired location and orientation, and it provides enough support even when there is limited bone. Already tells you how much you can do with 3D printing models. So the patient also receives the plastic model of his bone after the surgery, which he can use intensively to explain his or her solution to friends and family. And this added value in that it improves the doctor-patient communication by showing the anatomical model directly. So what's in the future? So we have bioprinting, we have cancer drug tests. This is what we are expecting. It's already being done, and we have personalized drugs. So what do I mean by bioprinting? So bioprinting, or organic printing as it's known, is the idea where you use a patient's own stem cell. So 3D dimensional bioprinting is the adaptation of 3D printing techniques to tissue engineering through the use of a bioink containing living cells and biomaterials. So the potential therapeutic interest in this type of 3D printing could change the face of reconstructive surgery. It can also increase precision and suppress of donor site of what we call immunosuppressive treatments. This could be good news for people who have failed liver due to heavy smoking and drinking. For example, you're able to print your livers now. And also, it's a good example for 3D printing of synthetic skin for transplanting to patients who have suffered severe burn injuries. For cancer drug test, bioprinted organs may also be used in the future by pharmaceutical industries to replace animal models for analyzing the toxicity of new drugs, for example. And when we're talking about personalized drugs, so the main idea behind 3D printing drugs is to design and develop medicines that are suited to individual needs. And in this way, we can easily adjust the size, the appearance, the shape, and the rate of delivery of a medicine. So this already tells you how much we can do with 3D printing. I will quickly take you through the opportunities that we foresee that are currently there in the 3D printing industry. And the first one is the application-driven approach. So the industry is shifting its focus to identifying the right applications for 3D printing rather than in developing new technologies. So we see this tendency, which is to gain attention from the financial world. So investments are not going to machine manufacturers anymore, but to companies and startups that apply 3D printing to create a real added value in specific domains. Companies are now looking at methodologies to stimulate 3D printing consultancy and co-creation. So now here the objective actually is to widen the pool of industries using 3D printing and thereby creating a market and demand for products rather than supply for a non-existing market. An example is a 3D printing company can work with manufacturing companies to develop applications through creation projects, combining 3D printing expertise with the manufacturing companies' knowledge of the industry, their market, and projects. I know it's not smooth sailing, of course, but when a company moves from traditional manufacturing to additive manufacturing, design engineers need to adapt a set of rules, and this is a move from design for manufacturing to design for additive manufacturing. Knowing what works for a design that's intended for metal casting isn't enough when you're making the switch to metal to 3D printing. For material development, as industries identify relevant applications for 3D printing, material manufacturers will be driven to develop and certify new materials to applications. A good example is BASF, company in Germany. They're now producing materials specifically for printing, which could take new materials out of the research and development labs into 3D printing production floors. So the rise of the application-driven approach that I mentioned earlier towards innovation printing is a contributing factor to the material development. So as industries identify relevant applications for 3D printing, material manufacturers will be driven to develop and certify new materials to suit those applications. For software, as industries work on integrating 3D printing into their production mix, the challenges are less about technology and more about economics. So the goal here is to reduce costs and to increase efficiency, and software plays a key role in doing this. So for example, software makes it possible to automate tasks through the 3D printing process. So you can automate manual labor during the preparation phase, also during and after production. It's also already a big help in making 3D printing scalable, efficient, and cutting the cost down. So we can improve productivity through simulating the 3D process, and simulation, it's a very essential tool to predict builder fields. And I believe through incorporating simulation into the 3D printing workflow, it will make it possible for production operators to stop potential building errors even before the build starts. So what do we expect for the future? We're going to see new adopters will enter the pool. And what do I mean? The research firm Gartner predicts that by 2021, 25% of surgeons will be practicing on 3D printed models of a patient prior to surgery. This means that 3D printing will move from obscure back office labs into the forefront as part of a strategy to improve surgical training and simulations. We will also see the government getting involved. We know it has not been easy for governments, even here in Europe, to see the bigger picture, because the term 3D printing has been used for everything, from rapid prototyping to serial manufacturing. This has made it difficult for governments to estimate the potentials and risks of 3D printing for citizens and what exactly they should seek to empower through policy making. Now, the main concerns for policy are the regulation of intellectual property and product liability. The underlying concern being 3D printing could do to the physical object what the internet has done to music and movies. So this is through changing business models and shifting all the value to the digital file. 3D printing will disrupt supply chains, but governments overestimate how much of the value is on the digital file. And a part of the value will shift from the object to the CAD file, and we need to think how the government should regulate these files. Finally, future expectation is on technology neutral interconnectivity and not proprietary solutions. So what do I mean? The global manufacturing market is currently valued at $12 trillion. So for 3D printing to unlock that potential and claim a bigger share of that 12 trillion market, the 3D printing industry needs to offer interoperability and technology neutral solutions. If industrial manufacturers want to be serious about 3D printing as a complementary manufacturing technology for final products, they simply cannot afford to be locked into proprietary solutions that limit their flexibility and choice. So what we suggest as a 3D printing is that industries should work together to promote a more open market model. The 3D printing industry needs to provide more control, more choice in materials and systems, and ultimately lower the costs. So thank you for the opportunity.